Welcome to the second video on the revision questions. This is the second set of revision questions that were given out, and it included two different questions. The first was 2017 paper 1 section A question 1, and the second was 2016 paper 1 section A question 2. So we're going to go through both of those solutions now. So the first question we have is to write this function f of x, which is equal to 2x squared minus 7x minus 10 in the form a bracket x plus h to be squared plus k. So this is called completing the square. So this question hadn't come up like this before. It came up once before, and it was looking at a quadratic that had the coefficient of x squared as 1, so it was slightly easier. This time, because of that 2 there, that's going to cause, well, it's going to make it just that little bit more difficult. So let's take a look at it and see how we can go on. So we have f of x equals 2x squared minus 7x minus 10. Now, the first step of completing the square is taking the square root of the first term. Now, because there's a 2 there, straight away we know, well, actually, that's not going to give us a perfect answer. It's not going to give us a whole number answer because 2 is not a perfect square. So what we're going to do, just to make our lives easier, is going to pull that 2 out. So we end up then with x squared minus 7 over 2x minus 5. Now, some people like to work in decimals. My advice would be to stick to fractions, but it is up to you. It is slightly easier to work in fractions, but I know some people really dislike working with them. So the same, it will work okay with decimals, but you will be reliant a lot more on your calculator as we like square numbers or as we divide numbers. So now let's look what's in the square bracket, and we're going to complete the square in what's in there. So if I open my bracket, I take the square root of the first term, which is just x. I then look at my middle term, which is minus 7 over 2x, and that will always guide my sign. So this is definitely going to have a negative sign, and it's going to be some number squared. Okay, so to figure out what else should go into the bracket, I'm going to work over here to the side, and I have minus 7 over 2 times x. Now this is my middle term, so when we square out a number, or when we square out a bracket, we'll look for, well, first of all, square the first, then we will first by the second and double it, and then the third piece is square the last. So this is the first by the second, and then we double it. So we first need to half of minus 7 over 2x, which is equal to minus 7 over 4. X, but remember it also got multiplied by the first term, so then we need to divide by x, so that just gives us minus 7 over 4, and that is what goes into the bracket here, minus 7 over 4. Okay, now because we have created a square bracket that wasn't there before, we then have to take away minus 7 over 4 squared, and we still have the minus 5 from earlier. So now we need to clean up, so 2 times x minus 7 over 4 squared. This will give us minus 49 over 16 minus 5. We're going to clean up our number here, so that's x minus 7 over 4 all to be squared, and when we clean this up we should get 129 over 16. So we're nearly finished, but notice how in the initial question here there was an a bracket and then plus a k. Now we have these square brackets, so we're going to multiply out the square brackets to get rid of them. So it'll be 2 by this bracket here, and it'll be 2 by minus 129 over 16, which is minus 129 over 8. So that is your answer. The next question is asking, write the minimum point of f, and notice the word hence. So basically they're telling you that you can actually use what you have in the previous part. So when you've done this before, you would have learned that there's really important things that we can do with this this form of a quadratic. So we take this term here, okay, and this gives us minus the x coefficient, and this piece here gives us the y, and that's of the minimum point. So the minimum point is going to be xy. So we always have to change our sign here, so we end up with 7 over 4, and it'll be minus 129 over 8. So very quick part there. The next question, part C, asks us, explain why f must have 2 real roots. Now, there are 2 ways to do this, and I'm going to work off the way that we'll always be able to use. So that's using this thing called the discriminant. Okay, and if you can remember, that's b squared minus 4ac. So if you remember your minus b formula, it's the little piece under the square root. So we have minus b plus or minus the square root of b squared minus 4ac. So if we work out the discriminant of this, our b in this case is 7. We're going to square it, minus 4 times 2 times minus 10. Now, the ABC refers to ax squared plus bx plus c equals 0. So it refers back to the coefficients in the initial quadratic. Okay, so when I work out the discriminant there, I get 49 plus 80, which works out at 129. Which is greater than 0. So if you remember, we had 3 different things about the discriminant. So if the discriminant was negative, so if it gave us a negative number, then it didn't have any real roots. And that's getting into the imaginary numbers, because we'll have a square root of a negative number. If the discriminant was equal to 0, it did have 2 real roots, but they were the 2 identical real roots. So they would, if you can imagine the graph, that quadratic graph would just touch the axis. Because it is greater than 0, then we can say that it has 2 distinct, so 2 different distinct real roots. Okay, so we can say therefore 2 distinct real roots. Another way you could have looked at this is about the minimum point. So if you looked at the minimum point, which we got in the previous part, it was 7, 4 and minus 1298 over 8. So the y-coordinate was a negative number. And because that y-coordinate of the minimum point was a negative number, it will have had to cut the axis twice. So it must have 2 real roots. But sometimes things like that, we may not always have the minimum point when we're doing a question like this, so the discriminant will always work. Now, part 2 of this part C asks us to write the roots of f of x equals 0 in the form p plus or minus root q. Now, straight away when you see that, people go minus b formula, and that's absolutely fine to use. You can go back to the initial quadratic that we have and use your minus b formula. However, you would have learned back when we did completing the square that we can use that form in order to get our roots. So that's the method that I'm going to use. Now, like I said, if you use minus b, you're going to get the same answer, but it is good to know this method because it is slightly easier. There's not as much calculations, and it's not as time consuming. And you're more likely to make a mistake in the minus b formula as you're subbing in all that information. So we start with the form that we made in the first part. So 2 bracket x minus 7 over 4 squared minus 129 over 8. We're then going to rearrange this. So we're going to bring the minus 129 over 8 across the equals. So that gives me equals 129 over 8. I'm then going to divide both sides by 2 to get rid of the 2 in front of this bracket. So I end up at 129 over 16. And then I'm going to square root it. So I just want this bracket as it is. So 7 over 4 is equal to the square root of 129 over 16. So if you notice, the bottom of that fraction is actually a perfect square. So we can use that. So that is the same as the square root of 129 all over the square root of 16. Rules of thirds. So when there is a fraction under the square root, we can separate it to the square root of the top line and the square root of the bottom line. So remember, our square root is a power of a half. So when we talk about the rules of thirds, we're also talking about the rules of indices. So x minus 7 over 4 is equal to the square root of 129, and I'm going to write the square root of 16 as 4. And then my last step is to bring across my 7 over 4 plus root 129 over 4. Now, I've purposely left something out here in the middle of the question. So if I can get you back to just this step here, where we applied the square root. So you'll notice that our final answer only has a plus in it, yet we were asked to get p plus or minus root q. So this is a really important thing that I want to draw your attention to. When you're doing the square root, we will always get two answers, and that is the plus and, well, the positive and the negative answer. But because if you think of the square root of 4, 2 by 2 gives us 4. But similarly, minus 2 by minus 2 also gives us 4. So a plus and a minus is the correct way to go when we get a square root of a number. So if I put in my plus and minus the whole way here, at this point here, not only will I have the plus, but I'll also have my minus. So when we're doing the square root of any number, we can always take the positive and the negative. And we've seen that in many, many cases. So it's just to really be aware of that. When we do the square root, the correct way to say it is we'll get the positive and the negative answer. So question 2 now. So find the range of values for which the absolute value of x minus 4 is greater than or equal to 2. So this is an algebraic inequality. So if we take the absolute value lines, or also known as the modulus lines, what that means is whatever the value in there is, we must take it as positive. So if x is a value such that x minus 4 is positive, then we just drop the absolute value lines. If it's a case that the value of x makes x minus 4 negative, we would take the positive of it. So we've seen these absolute value lines before, and you'll continue to see them in different places in the course. While we're working here, we're in a little bit of trouble because we need to know if it's positive or negative, because that can affect that greater than or equal to sign, because we're not dealing with an equation, we're dealing with an inequality. So the way we work with this is we say that whatever x minus 4 is, whether it is negative or positive, when we square it, it will 100% be positive. Okay, and that's kind of leading back to what we just did at the last part of question 1. So when you square any real number, it will always give you a positive number. So if we square a positive number, it's positive. If we square a negative number, it's also positive. So we want to square this number here. So we'll do x squared minus 8x plus 16 is greater than or equal to 4. So let's rearrange that. X squared minus 8x, and we'll end up at plus 16 minus 4 is greater than or equal to 0. X squared minus 8x plus 12 greater than or equal to 0. So now we have a quadratic inequality. So if you remember with the quadratic inequalities, we can't really solve an inequality at this point. We instead have to convert this to an equation which then we can solve, equal 0. Okay, so we can use our guide number method. I'm going to skip the guide number and just go straight to the answer, but using the guide number will be 12, and you'll work with the factors at 12, and what we should end up with is x minus 6 and x minus 2, which will give us two answers, x equals 6 and x equals 2. So we're not finished yet, so what we're going to use is the sketch method to make sure we have the correct range of values. So I'm going to draw out my graph here, and if I go back here to my quadratic, it is a positive quadratic, so hopefully we all know what a positive quadratic looks like at this stage. So it's our U-shaped here. we have 2 points, so this is x equals 2, and this one here is x equals 6. Now, if we go back to the line above it, we wanted where it was greater than or equal to 0. So I'm going to write this in here. So we have x squared minus 8x plus 12 is greater than or equal to 0. So where is it greater than 0? Where is y above the x-axis? And the answer is here, where I'm showing in red. So the values are where x is less than or equal to 2, or where x is greater than or equal to 6. So if we wanted to put that together, it'll be 2 is greater than or equal to x is greater than or equal to 6. But really, at this point, because they're two separate pieces of information, we're better to keep it as it is here in two separate pieces. Okay? So if x is less than or equal to 2, or x is greater than or equal to 6. So part B then is solving simultaneous equations, and you might notice here that we have a nonlinear and a linear. So our method for simultaneous equations where we have a linear and a nonlinear is the substitution method. So the first step is we take our linear, which in this case is 2x plus 3y equals minus 1, and we rearrange it to isolate one of the terms. Now, it really doesn't matter which one you isolate. I'm going to isolate x because it's slightly easier to sub in x than y. Now, very slightly. So x is equal to minus 1 over, or minus 3y all over 2. Now, we go to our nonlinear and we sub in that value of x. So our nonlinear is going to be minus 1 minus 3y over 2, all to be squared, plus minus 1 minus 3y over 2 times y, plus 2y squared equals 4. So we've got a little bit of work to do here. So remember, when I'm squaring a fraction, we square the top, so I'll just write that as a bracket squared, and square the bottom, so the bottom just becomes 4. Here we end up, I'm going to pull the y in front, so we get minus 1 minus 3y all over 2 plus 2y squared equals 4. Now at this point, some people really dislike fractions, and what we can do at this point to get rid of the fraction is multiply the whole way across by 4. So we end up at minus 1 minus 3y squared plus 2y by minus 1 minus 3y plus 2y squared, apologies, plus 8y squared, because remember we're multiplying by 4, equals 16. I've just put the bracket in on the wrong place here, so it's that whole thing squared. So let's work this out. So it's square the first, we want to multiply the first by the second, so that gives us plus 3y, and then we double it, so that ends up as plus 6y, and square the second, so minus 3y all to be squared gives us plus 9y squared. Multiplying out this bracket, we get minus 2y minus 6y squared plus 8y squared equals 16. So we'll do a little bit of cleanup on that. We have some things in common. So we have the y squared here, a y squared here, and a y squared here. We also have a y here and a y here. Excuse me. So we have plus 9y squared minus 6y squared plus 8y squared. So that should leave us with 11y squared. Plus 6y minus 2y, so that's plus 4y. We also have a 1 plus 1, and I'm going to bring the 16 across, equals 0. And we end up with 11y squared plus 4y minus 15 equals 0. So I'm going to move back up here, just up here to finish. So we end up with 11y squared plus 4y minus 15 equals 0. So at this point you have two options. We need to solve this quadratic, so you can either do it using the guide number method, or if you have numbers like this that maybe you're feeling, oh, I'm not sure how well I'll do with a guide number that's so big, you might decide to go straight to minus b formula. I'm going to use the guide number method just to show you how we would work this out. So we have the guide number here is 15 multiplied by 11. So that gives us a minus 15, so it's a minus 165. Now, I want to get factors that will give you a plus 4. So what you might actually notice is 11 and 15 will do that. And that's how we got to our guide number. And you'll often see that that's the case. However, in this case, I need a plus 15 and a minus 11 because what I'm looking for is a plus 4 there in the middle. So rewriting that, I get 11y squared minus 11y plus 15y minus 15 equals 0. So 11y, I'm going to pull that out, it's common, and I get y minus 1 plus 15, and I get y minus 1 equals 0, and I get 11y plus 15, and the second factor is y minus 1 equals 0. So I get 11y plus 15 equals 0, and y minus 1 equals 0. So I get one of my factors is y equals 1. The other factor is minus 15 over 11. Sorry, one of my two roots. So I get y equals 1 is one of my roots, and the other root is y is equal to minus 15 over 11. So it doesn't look terribly pretty, but it is a good answer. So then I need to go back, and I'm going to use the last formula I came up with for x, because x is isolated. So I can go back to the original, either one. I would advise not to go back to the nonlinear because it's going to be more complicated. Go back to the linear and sub it in. However, instead of just using the linear as was in the beginning, we're going to use the one where x is already isolated because it will give us an answer very quick. So you'll see what I mean here. So let's first of all work where y is equal to minus 15 over 11. So x is equal to minus 1 minus 3 bracket minus 15 over 11 all over 2. So x is equal to minus 1. And this becomes plus 45 over 11 all over 2. And if you want to at this point stick that into your calculator, you should get 34 over 22. So that point is 34 over 22 and minus 15 over 11. So the second point then is where y is equal to 1. So subbing that in, I get x is equal to minus 1 minus 3 times 1 all over 2, which is minus 4 over 2, which gives us minus 2. So the point is minus 2, 1. There are two answers. So it's always a good idea, especially when you see all these workings, it can be very easy not to see the answer. So I'm going to highlight my two answers very clearly here. So if this wasn't an exam situation, the examiner can see very quickly where my working is. Now I have cut off half the page, and obviously working on the computer is slightly harder, but it is a good idea for questions like this that you know are going to go on for a while. Maybe split your page in half down the middle so you can work on the left hand side in one column and then work up towards a column on the right hand side then as well.